The generalized burning number of graphs. Introduction to graph burning. Graph burning is a process modeling the spread of influence or contagion across a network. It involves sequentially selecting nodes to ignite, which then propagate fire to their neighbors. The goal is to determine the maximum number of steps needed to burn the entire graph. Basics, Basic definition and concepts. A graph consists of vectors, nodes connected by edges links. The burning process begins with initialized burning vertices called sources. The burning number of graph is the smallest number of steps needed to burn all vertices. Standard burning number. The standard burning number is a measure of how quickly a graph can be fully burned. It provides a way to compare different networks based on their spread dynamics. Determining the burning number is an NP-hard problem in general graphs. Motivation for generalized burning number. Real world networks often have complex structures that require a real world networks often have complex structures that require a more flexible model. The generalized burning number extends the traditional concept to include multiple fire sources per step. It helps better understand spreading processes in networks with diverse dynamics. Definition of the generalized burning number. The generalized burning number allows multiple vertices to be ignited simultaneously in each step. It is defined as the minimum number of steps needed to burn the entire graph with multiple sources. This concept captures the efficiency of multiple simultaneous contagion sources. Formal mathematical framework. For a graph, G is equal to V comma E. A burning sequence is a sequence of set of vertices. Each set in the sequence corresponds to vertices ignited at a specific step. The generalized burning number is the smallest length of such a sequence covering all vertices. Relationship with standard burning number. Relationship with standard burning number. The generalized burning number reduces to the standard burning number when only one vertex is ignited per step. It provides an upper bound for the spreading time in networks with multiple ignition points. The concept allows for more efficient burning strategies in complex networks. Applications of generalized burning number. It models the spread of information, diseases, or influence in social networks. Useful in designing strategies for rapid dissemination of containment. It applies to epidemiology, marketing, and information security. Computational complexity. Calculating the generalized burning number is computationally challenging for arbitrary graphs. Exact algorithms are often infeasible for large networks due to NP hardness. Approximation algorithms and bonds are used for practical purposes. Moving to the next slide. Known results and bonds. For certain classes of graphs, exact values or tight bonds are known. For example, complete graphs and paths have well studied burning parameters. Researchers have established upper and lower bounds for various graph families. Strategies for minimizing the burning number. Optical Optimal placement of initial ignition vertices is crucial. Distributing sources to maximize coverage reduces overall burning time. Heuristic algorithms are often employed to find near optimal solutions. Recent research developments. Studies focus on improving bonds and approximation methods. Extending the concept to weighted and directed graph is an ongoing area. Researchers are exploring the interplay between graph structure and burning efficiency. Open problems and challenges. Determining the exact generalized burning number for arbitrary graphs remains open. Developing efficient algorithms for large scale network is a significant challenge. Understanding the impact of graph parameters like diameter and degree on burning number is ongoing. Future directions in research. Integration of probabilistic models to account for uncertainty in spreading. Exploration of dynamic graphs where edges change over time. Application of machine learning techniques to predict and optimize burning strategies. Summary of key points. The generalized burning number extends the classical concept to multiple simultaneous ignitions. It provides insights into the efficiency of spreading processes in complex networks. Ongoing research aims to better understand its property and computational aspects. Summary of key points. The generalized burning number extends the classical concept to multiple simultaneous ignitions. It provides insights into the efficiency of spreading processes in complex networks. Ongoing research aims to better understand its properties and computational aspects. Conclusion and references. The study of the generalized burning number is vital for modeling real-world spreading phenomena. Advances in this area can influence network design, epidemic control, and information dissemination. For further reading, consult recent publications in graph theory and network science journals.